Back to geometry. This is going to be our third set of notes for Unit 1. And today we're going to be talking about the distance formula. So the distance formula looks like this. It's the distance equals the square root, the long square root sign, of x sub 2 minus, sorry, not plus, minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And all that means is that this is going to be the x second point, so this would be like this x right here, right? And then this would be this x right here, okay? That's all those two mean. All right, so what is the distance formula for? Well, let's say we have this graph right here, and we want to find the distance from this point to this point, but we can't really count by units because it's not going at a steady pace. I mean, it's going at a steady pace. It's just not going unit by unit, right? So see right here at this point, this is in between -2 and 3. Right here, it looks like it's on 3, but again, it's right here between -3 and 4. So this distance formula is great when we're trying to find the length of that line right there. Okay, so let's go ahead and find the points here. If we go ahead and let's see if I can zoom in a little bit more, see a little clearer. All right, so we have -1, 2, 3, 4, 5 is our x, and 1, 2, 3. So we have -3 comma 5. And then for our second point, we have 1, 2, -2, and -3. So these are our 2 points that we're going to be using to plug into our formula. I'm just going to move these over here, and we can go ahead and plug them in. So the distance is x2. So this is my x2. Well, if you'd like, we can always, you know, do this in a way where we know exactly which ones need to be plugged in. So we have -2 minus. And remember, when we plug in something, we're using the substitution, right? So when we do substitution, it's always good to put it in a parentheses for cases like this, because we have x2 minus a negative, right? Our x1 is -5. So that reminds us that we need to combine these negative terms, okay? Plus our y2, which is going to be -3 minus our y1, and y1 is +3. So if you'd like to use a substitution, you can, you could still put the parentheses around these, but since this is positive, I know it's not going to change my negative. So I'm just going to leave it without that. All right, so right here we have a negative and a negative, which turns positive. So I have -2, let me make this a little nicer, -2 plus 5 squared plus -3 minus 3 is -6 squared. And this is going to give me a 3 squared plus -6 squared. I'm going to bring that down. All right, so now we have 3 squared, which is 9, and 6 squared, which is 36. And this is -6 times -6, right? That's what that means. So -6 times -6, and two negatives make a positive. That's why our 36 is positive, okay? In case you make those little mistakes. Now, we can't forget, which happens all the time, that this whole problem, let's see if I use my highlighter, is in this square root bar, right? So in that case, oh, what happened here? In that case, we need to simplify this and square root our final answer. Okay, so 9 plus 36 is 45. And the square root of 45 is not a perfect square, so we are going to need our calculator. And when you use your calculator, please round to the 10th place for all of these problems. So when I round, I get approximately 6.7. Now, whenever you're rounding for these problems, please use the approximate sign. It does not equal 6.7, so we can't use the equal sign. We can say it's about 6.7, which is what that approximate sign means. All right, let's go ahead and scroll down. You can do these two on your own. So we have the midpoint formula, and the midpoint formula is what we use to find a point that is in the middle of a segment or a line. So, well, a segment, I should say. So if I have a coordinate plane, and I have this point here that is 2, comma 2, and then I have another point here that is -2, comma -2. It's going to be somewhere around here. And they want to know what point is right in the middle of these 2 points. Well, just looking at it, I know that it's going to be the origin. I know it's going to be 0.0, comma 0. Okay, but we can use but we can use the midpoint formula for harder problems. So for something like this. So let's go ahead and give you that formula. Midpoint equals the average of your x's. So you're going to take your x1 and add your x2, and you're going to divide that answer by 2. And then your y's, and divide it by 2. Now, technically, this is x1 plus x2, y1 plus y2, but since we're only dealing with 2 points, I don't think it's necessary in this case to remember that for your formula, okay? But just keep that in mind that this x is going to go to this x is going to go to this x, right? To find the midpoint of those lines. So let's plug in our numbers for number 4. Let's test it out. So the midpoint equals my first x, which is 7, plus my second x, which is 9. Divide all that by 2. And then my y is going to be -5 plus -1. And we know that a negative and a positive make a negative, so I am just going to write -1. Okay, so let's go ahead and reduce this. So we have 7 plus 9 over 2 is going to be our x. And so 7 plus 9 is 16 over 2, which reduces to 8. So I know that my x equals 8. Let me scroll over, get some more room. Okay, so to find my y's, I have -5 minus 1 divided by 2 is going to be my y. So negative and negative means that we add. 5 plus 1 is 6. It's going to be -6. And then -6 divided by 2 is -3. So my y is -3. So I'm going to erase this right here. And I know that my midpoint, according to our formula, is 8, comma, -3. All right, let's look at another application that we can use our midpoint formula for. So we can use our midpoint formula to find a missing endpoint, okay? So let's say, like the example we had before, when I drew that coordinate plane, and we had the 2, comma 2, and then we have the -2, comma -2, right? And we knew that our midpoint is the origin in this case, okay? But what if they said, hey, we don't know our midpoint. I mean, we don't know our endpoint, but we do know the midpoint. Okay, if they say that 2, 2 is one endpoint and the midpoint is 0, 0, what is the other point? We know it's going to be in this vicinity somewhere. Okay, well, other than me telling you what the answer was, you can use the formula to work backwards. Okay, so let's take a look at this. Here's our midpoint formula again. Midpoint equals our averages of our x's and the averages of our y's. Okay. And so they say that we have the midpoint already, so we can plug that into this side of our formula. And we have our 1x, okay? We're going to plug that one into 1x. And we have our y's. okay? So we can plug that in right here. We have 1y. So you can use the midpoint formula, right, to plug in what you have and find your missing variables. Okay, so let's take a look at how that might look. The midpoint is -1, comma 2. Our x, the average of our x's is going to be 3 plus x over 2. We have that 3, remember, from right here. And then the average of our y's is going to be -5 plus y all divided by 2. Well, since this portion of our formula is finding our x, then we can set up an equation where -1 equals 3 plus x over 2 and solve for x. We can do the same thing with our y's. We know that this is going to equal 2 according to our formula, so 2 equals -5 plus y over 2. So we're going to solve for x, make some more space. To get x by itself, we're going to multiply both sides by 2. Now we have -2 equals 3 plus x. The 2's were canceled out. Now we're going to bring our 3 to the other side, and we have -5 equals x. All right, we just found our x. So let's go ahead and do the same with our y. We have 2 equals -5 plus y divided by 2. We're going to multiply both sides by 2 to cancel that out. Now we have 4 equals -5 plus y. Add 5 to both sides. 9 equals y. Okay, so we have found our missing endpoint. All that's left to do is rewrite it so that Miss Ariana can find your answers.